Relative or local mean, very good. Negative 1.22, negative 13.48.
It's an inflection point.
Inflection point, very good. 0, 5. Local or relative max, very good. 0.55, 2.31.
Another inflection point.
Very good. And finally, 1, 0 is
another min.
A relative or local min. Perfect. That's all we need. Now we're ready to graph. Okay, let me try and plan ahead a little bit. This is a problem, the negative 27 and negative 13. So it goes as low as negative 27 on the y-axis, of course, and as high as 5 on the y-axis. So I think I'm going to take a scale of 5. So I'm going to say 5, 10, 15, 20, 25, 30, and 5 here. On the x-axis, anywhere between negative 3 and 2. 1, 2, 3, 1, 2. So this is in units of 5, and this is in units of 1. Okay, now I will plot the points that I have. So roughly negative 3, 0. This is 1 point, this point. Negative 3, 0. X-intercept. Now negative 2, negative 27. Negative 2, negative 27 is somewhere here. Then we have negative 1.22, negative 13. 1.22, negative 13. Then the next one, negative 0.6, 0. Somewhere in the middle there. 0, 5. 0.55. It's going up to 2.3. 0.55 to 2.3. Hard to present. And then 1, 0. So I have all the points, and now we're ready. Ready? Coming from positive infinity. Oh. Concave up, concave down, concave up. Okay. So coming from positive infinity and opening up, decreasing, and coming to this x-intercept. Continue to a local minimum of negative 2, negative 27, local minimum, still opening up, still decreasing. Where it turns. Now it increases to this point, which is an inflection point. Increasing to this point, which is an inflection point. It will turn in the sense that it will change concavity. Now it's still increasing. It's increasing to the x-intercept, opening down. Increasing to the x-intercept, opening down. Reaching a local maximum, increasing, opening down, local maximum 0, 5. It continues to decrease to this inflection point. At this point, it changes concavity. And it reaches a point on the x-axis where it turns because it changed concavity at this point, 0.55, 2.31. And now it's increasing to the point of intersection with the x-axis, I meant to say, the 1, 0, the x-intercept, and going up to infinity. It turns, it has a local minimum here at 1, 0, and then goes up to infinity. So this is our f of x. We always have to write what function we graph, 3x to the 4th plus 4x cubed minus 12x squared and plus 5. Without organizing the data, without presenting all the work, you will only copy from the graphing calculator, which is not what I'm interested in. Anyone can do that.
Why does it have 3 intercepts?
I'm
3x
sorry?
intercepts.
I'm
Why
sorry?
does it have 3x intercepts?
Instead of 4?
Yes.
Because this is the same. Multiplicity 2, it has a turn.
Okay.
Good. Very good question. Anything else? Anything else? Do we have anything else to look at? Other questions? Other problems? Questions on all this? Anything? So if I were you, I will redo this problem slowly again and put these numbers so the table is a little has more air in it, so it's clear, more clear and better and easier to see. Because of course these were too close and I could not insert the negative 1.22. Here it kind of worked, but it's not, it doesn't look nice. It's functional, it's correct, but it doesn't look 100% nice. So please redo that problem from the beginning till the end and you'll see how rewarding that is at the end. Okay, other questions for me? Very good question, thank you. Other questions for me? Okay, so let's look at real quick at a slant asymptote situation. I want to show you one. And then I would like to look at applications, or we look at applications. We are on page 231. Where's my keyboard? 231. So let's take a look. Maybe we should start with an application and then choose. Oh, this is a good one. This is a good one to find. We're not going to graph unless you want me to, but I would like to. I'm not going to ask you to graph these functions that have weird numbers. Even the one that we looked at, right? Even this one has, you know, we had all sorts of, which is fine. That is fine. But in a word problem, I think just understanding what's happening is good enough. Because you will have graphs like these to look at. But if you want to work on a problem and also graph it, I'm fine with that. Whatever you decide. Okay, ready?
46 will have a slant asymptote.
Very good. Let's take a look. Where is 46? 46. Yes, indeed, 46 is a good one. Thank you for picking that. So f of x equals x squared minus 4 divided by x plus 3. Exactly. And the reason is, what is the degree of the top and what is the degree of the denominator?
The degree of the numerator is n plus 1.
Is
whereas
2 and the degree of the denominator is 1. So this is exactly 1 unit higher in the numerator. And this is the only one that has a slant asymptote. Perfect. So let's prepare the function first for the whole thing. How would you write the numerator? Anyone?
X plus 2 times x minus 2.
Very good. Can anyone give us the domain of this function?
It's negative infinity, -3, union, -3 to infinity.
Excellent. That's all you need to write. If you write this, I don't need it on the side. It's very clear to me. Once you wrote this, whatever you want to write, whatever you want to, you can write undefined here, do whatever you want. But once I see this, I know you know what you mean. Can anyone give us these limits? Let's write them. Okay, so limit x squared minus 4 over x plus 3 as x approaches infinity. Where does the numerator go? Anyone?
Infinity.
Good. The denominator?
Infinity.
Good. What do we do with the limit of a rational function in the case of infinity over infinity? What do we do?
Apply L'Hopital's rule.
Very good. The derivative of the top is?
Zero.
Good. The derivative of the denominator is?
1.
Good. So where does this go now?
Infinity.
Very good. So this was here. Now let's look at limit as x approaches negative infinity. You understand that nothing changes, but the limit will be what? Still we get the same thing, but now when we plug in x approaches negative infinity, where does this go?
Negative.
That's it. Done. Now we need these two. So limit as x approaches negative 3 from the left of, and it's easier if I write it factors this time. You will see in a moment why. And then limit as x approaches negative 3 from the right from x plus 2, x minus 2 over x plus 3. The numerator, because it's x squared minus 4, when x approaches negative 3, will be a positive number. I hope you agree with that. Right? Negative 3 squared is 9. 9 minus 4 will be 5. So the top is positive. What about the denominator? Where does this go from the left of negative 3? What sign?
Negative.
That's it. So then we know this must be negative infinity. And now from negative 3 to from the right of negative 3, where will this go? Just a sign.
Infinity.
The sign, this is 0, right? This is 0. When we plug in its vertical asymptote, right? X equals negative 3 is a vertical asymptote. The answer has to be on infinity, so the denominator is no hope. The denominator is 0. Negative 3 plus 3 is 0 here as well. But negative 3 from the right of negative 3, what is the sign of this? So I can put it here. So I can know the sign of the infinity.
Positive.
Positive. Okay? Is this clear? We've done this in chapter 1. All this. So when you plug in negative 3, you get 0. But you need a sign because you know it's going to be an infinity. So this is negative 3 is a vertical asymptote. So negative infinity from the left, positive infinity from the right. I have to plug in 0. Can anyone plug in 0 here and tell me the answer so I can write it here?
Negative 4 over 3.
Excellent. I'm going to move it a little bit to the left, to the right. Excellent. So a negative 4/3. Because now when we set this equal to 0, can anyone give us when a fraction is 0, first of all?
When the numerator is equal
When
to
the numerator is 0. So when the numerator is 0, we get x equals and x equals. Anyone?
2 and negative 2.
Very good. So careful. Negative 2 and 2. Everything has to be in ascending order. Make sure all the time. Negative 3, negative 2, 0 to infinity. So we finished with this. All this work was just for the function. Now we're ready to move on to the first derivative. Okay. So f prime, and I'm going to write the function here one more time. So this is x squared minus 4 over x plus 3. What rule are we going to apply? Someone I haven't heard from today, like Katie. Katie, I haven't heard from you.
The quotient rule?
Quotient rule, very good. The numerator prime is
2x.
good times the denominator minus the numerator times the denominator prime. Katie, are you with us?
Yes.
Yes. So what is the derivative of the denominator, please?
X plus 3 is 1.
Good. Excellent. So then we continue with f prime. I will distribute. I have no choice. So 2x squared plus 6x minus x squared plus 4 divided by x plus 3 squared. Ugly situation. So I have x squared plus 6x plus 4 divided by x plus 3 squared. Why ugly? Because when I set this equal to 0, because it's undefined at -3, but so is the function. So that's not a critical number. If the function is not defined there, it cannot be a critical number. And quickly, I'll find the solutions for x squared plus 6x plus 4 equals 0. A fraction is 0 only when the top is 0. When the denominator is 0, the function is undefined. Okay, so apps and 9, and it's quadratic again. So the first coefficient is 1, the second coefficient is 6, and the last coefficient is 4. Good, solve. X equals -5.2 and x equals -0.8. Just to mess me up, right? So a -0.8 and -5.2. Now, when I study the sign, I will not study the sign of the denominator because it's always positive. And I know how this looks like. So it's positive to the left. You can plug in -10, is negative in between, and it's positive outside. At this point, the moment of truth. If these two do not work well together, then I know I have a mistake somewhere. Not before I determine this number, and I determine this number for -0.8. So I will put the function in the graphing calculator. Please make sure that you put parentheses for the numerator, x squared, and then -4, close, divided by, in parentheses, x plus 3. And now go to second and table, and I need -5.2 and -0.8. Okay, so the first one is -10.5, and the next one, the second one is -1.5. Okay, now I'm ready to check my table, because the table will enable me to graph.